Okay, so let's say we want to calculate the Fourier cosine series for this function. How do you do it? Well, it's very similar to how you do the Fourier series, except that now it's easier because you don't have to do 3 intervals, you just 2 intervals. Okay. So let's try that. A0. What's our L?
2.
Is 0 to 2, so 2 will be the L. So it's 1 over 2, integral from 0 to 2 of 2x minus x squared dx, which is 1 over 2 x squared minus 1/3 x cubed. And you plug in 2 and 0, so you get 4 minus 8 over 3 times 1/2, which is 2 minus 4/3. That's 6 over 3, so it'll be 2/3. Okay, and then an is 2 over 2, 0 to 2, 2x minus x squared times cosine n pi over 2x dx. And then, let's see. Okay, so when you see this formula, just keep in mind that this 2 comes from the doubling trick, okay? And the domain is no longer symmetric. So I see a common mistake that people make here, which is 2x is an odd, this is even, so multiplying them gives you an odd function, and they're happy to say, therefore the integral is 0. They'll be wrong. Why? Because the domain is not symmetric, okay? So that's the common mistake that people have when calculating the Fourier cosine series. Okay. So we don't want to do that. We really have to do the integral. Plus minus d integral 2x minus x squared differentiates to 2 minus 2x, differentiates to negative 2, differentiating again you get 0. Cosine n pi over 2, you put it on the integration column. When you integrate, integral of cosine gives you sine, but because you're integrating, the reverse chain rule says the reciprocal of this number should be in front, right? So 2 over n pi comes in front, and then you put another reciprocal. So if you integrate again, you're going to get 4 over n squared pi squared. Integral of sine is negative cosine. Integrate again, you get negative 4 cosine 8 over n cubed pi cubed sine n pi over 2x. And then you have plus minus plus minus. So the integral here is, right, so 2 over 2 is 1. That's nice. And you have to read off the values going that way, right? Go down. So it's 2x minus x squared. And then it's 2 over n pi sine n pi over 2x. Okay. Then minus times minus is plus, so it'll be 2 minus 2x, and then 4 over n squared pi squared, and cosine n pi over 2x, and then minus, because of a minus 2 times 8 is, actually, when you do this, it'll be still plus. Negative 2 times negative 8 is positive 16, n cubed pi cubed sine n pi over 2 x, and then you're plugging in 2 and 0. And the nice thing about sines is that when you plug in 2, you get sine n pi, those are 0, so none of these give you anything else. When you plug in 0, sine of 0 are 0 as well. So the only contribution you get are these ones, okay? let's write down what happens. If you plug in 2 in here, 2 minus 4 is negative 2. Negative times 4 is negative 8 over n squared pi squared. And then, when 2 goes here, you get cosine n pi, which is negative 1 to the nth power. Right? Okay. And then when you plug in 0, here, it's 0. Cosine 0 is 1. When you plug in 0 here, 2 times 4 is 8. So again, you subtract 8 over n squared pi squared times 1. Okay? So that said, if we factor out the negative 8 over n squared pi squared, then we can simplify this as negative 1 to the nth power plus 1. So now the final answer would be that 2x minus x squared is equal to 2/3 plus summation of negative 8 over n squared pi squared, negative 1 to the nth power plus 1, cosine n pi over 2x, n from 1 through infinity. So that's the answer. Any mistakes? I think this is correct.